Hello, everyone. Thank you for being here. I am an architect and researcher from Peru. Since a very young age, I have felt a deep connection between architecture, science, and the cosmos. Perhaps because I grew up in a city with clear skies and where the Boyden Observatory once spread. Now I am research associate at the JSP program of the Blue Marble Space Institute of Science, where I collaborate on the design of human habitats for the Moon and Mars. Thank you for being here and accompanying me on this small journey. What will happen to the history of architecture when we are not longer on Earth? Before I begin, I want to mention that I am a bit sick with my throat and I am still learning English, so my pronunciation may not be perfect. I hope you can understand. Astronomical architecture, from its origin, has been a bridge between Earth and the sky. An emblematic example is a Yantar Mantar Observatory, built in 1738 by Maharaja Jai Singh II in Jaipur, India. Its name comes from Sanskrit. Yantar means instrument, and mantar derived from mantra, or formula for thinking. This observatory is not used a set of astronomical instruments, but a monumental architectural work. Among its 20 structures, the San Yantra stands out. The largest sundial in the world, with 34-meter base and 23-meter height, capable of measuring solar time with a precision of 2 seconds. Every element of Yantar Mantar was designed on a human scale to be worked through inhabited. Here, this architecture not only contains astronomical knowledge, it embodies it. For Jason II, it was also a way to preserve a millennia-old Indian astronomical tradition in the face of foreign influence. Today, Yantar Mantar still stands, not just as heritage, but a symbol of a time when looking at the sky was also a way of understanding who we are. Since ancient times, civilizations have built structure to observe and understand the sky. This architecture reflects belief, collective knowledge, and deep relationship with the natural. An enigmatic example is Napta Playa, megalithic site located in the Nubian desert in southern Egypt. Some studies suggest that these structures arranged in stone circles may have yet astronomical functions, such as orientation toward the summer solstice, revealing an early understanding of celestial cycles. However, the exact use remain under study. In my country, Chanquillo in northern Peru is a unique use of the pre-Columbian world. It consists of 13,000 lines along her reeds, forming the oldest solar calendar in the Americas, built over 2,300 years ago. Moving into the modern era, the invention of the telescopes changed our way of seeing the universe. Galileo Galilei in the 17th century used his own telescope design to validate the heliocentric theory and observe Jupiter satellites, laying the foundations of modern astronomy. And in our contemporary era, the James Webb Space Telescope represents the greatest technical and collaborative challenge in the history of astronomical observation. Its foldable design and sunshades are true fifth of architectural engineering under extreme conditions. This structure of stone, adobe, metal, or nanomaterials show that architecture has been and continues to be a means of extending the human gaze beyond Earth. The humanity project itself towards the World Astronomical Observatory must also evolve. Today, imagining an observatory it means transferring centuries of scientific architecture, its symbols, functionality, and legacy to radically different conditions, reduce gravity, constant exposure to cosmic radiation, and extreme temperatures. This slide shows two possible scenarios generated by artificial intelligence, a stationary observatory on a celestial body, such as the moon or a natural satellite, and another integrated into a Martian habitat. Both designs pose the same questions. How do we reimagine observational architecture in an environment where even the horizon behaves different from Earth? The challenges are many. On Mars, for example, the cycle, planetary storm, and the thin atmosphere affect both visibility and physical structure. Furthermore, in the absence of atmosphere and magnetosphere, as on the moon, architecture shielding becomes an essential design component. Today, the use of lunar and Martian regolith as a construction resource is being studied, exploring 3D printing technique in situ and inflatable or same construction models. My objective. In this research, I propose an architecture perspective on observatories as a space that condenses knowledge, memory, and identity. The main objective is to explore how architectural designs of terrestrial observatories can be adapted to space environments, incorporating functional and technological criteria without losing their scientific value or historical dimension. In this slide, I compare two icons of scientific architecture, the Arecibo Observatory in Puerto Rico and the International Space Station. Both are structure designed to observe, experiment, and expand human knowledge. But they do so from radically different environmental scales and architectural principles. The Arecibo Observatory, inaugurated in 1963, was for decades the largest radio telescope in in the world. It was responsible for crucial discoveries such as the first exoplanet in 1992 and data that led to the Nobel Prize in Physics in 1993. However, its collapse in 2020 revealed the limits of large terrestrial infrastructure exposed to extreme environmental conditions, such as tropical humidity and structural corrosion. It also highlighted the lack of preventive maintenance in remote environments. In contrast, the International Space Station, active since 1998, is a model of modular and adaptive architecture capable of housing up to 16 pressurized modules. The ISS has hosted astronauts from 19 nationalities and represents a global effort in space architecture. Preliminary conclusion. This image belongs to the film by George Méliès, based on the novel From the Earth to the Moon by Jules Verne, a capsule in the shape of a bullet embedded itself in the moon's eye. Grotesque and sublime, and yet something fundamental is born here. The space imaginary as an architectural act. Decades later, fiction gives way to the project Werner von Braun in 50 to propose a rotating space station in the shape of a ring, a toroidal, that generates an artificial gravity by centrifugal force. The design inaugurates the orbital typology in inhabitable modules arranged radially as a structural core and movable habitable perimeter. It is the first time architecture is seriously considered in the void still within mechanical coordinates, but with spatial and gravitational logic. Comparing the model, von Braun offers symmetry and control. The International Space Station is modular, fragmented, with adaptive growth, and the AI-generated designs suggest more organic, speculative, perhaps even emotional forms. Here arises an essential architectural question: what formal language corresponds to the cosmos? A function is not longer enough form also communicates mission, belonging, identity. Kubrick, with his clinical eye, brings architecture into symbolic language in these signs. The astronaut in a red suit entering a white capsule. Architecture is the silent protagonist. Every element is governed by rigorous composition. The vanishing nice converts precisely at the center, guiding our gaze like in an axial plane. The orthogonal planes, color contrast, and perfect symmetry generates hypnotic, almost ceremonial effects. The space is controlled, enclosed, purified. Kubrick turned architecture into visual language and reminds us that the way space is organized always organize our emotion, perception, and question. To close this presentation, I want to share a few phrases that architecture is not only technique, but also memory, culture, and vision. And that even beyond Earth, we can continue to build with meaning, with roots, and with purpose. Thank you for joining me on this journey through the past, present, and future of astronomical observatories. Here you find my contact in case you'd like to chat, share, or collaborate. Thanks again to the conference committee, my mentors, and all of you for your time. Thank you.